Hello friends, you are watching Master Mechanic YouTube channel. In this video we learn about what is variable valve timing and its function. Variable valve timing (VVT) is a technology used in internal combustion engines to optimize the timing of the opening and closing of the engine's intake and exhaust valves. This system adjusts the position of the camshaft relative to the crankshaft in real time, based on engine speed, load, and driving conditions. By varying the timing of the valves, VVT improves engine efficiency, performance, and emissions. Now let's see, how does VVT work? In a traditional engine, the valve timing is fixed, meaning the intake and exhaust valves open and close at the same time during every engine cycle. However, engine performance requirements change with engine speed, RPM, and load. For example, at low speeds, the engine needs more torque, while at higher speeds, the engine needs more power. VVT systems allow the camshaft, the component responsible for operating the valves, to be adjusted in a way that matches the current operating conditions. The most common way to implement VVT is by using an oil pressure-driven mechanism to rotate the camshaft or adjust cam phasing. Now learn about types of VVT system. VVT, variable valve timing, only adjusts the timing of the valves, i.e., when the valves open and close. VVT, variable valve timing, only adjusts the timing of the valves, i.e., when the valves open and close. VVT-i, variable valve timing with intelligence, a more advanced system, used by Toyota, that adjusts valve timing and has a more sophisticated control mechanism for better fuel efficiency and performance. VTEC, variable valve timing and lift electronic control. Developed by Honda, this system not only adjusts valve timing but also changes the lift height of the valves at higher RPMs. VANOS, variable nockenwellen steering. Used by BMW, the system adjusts the timing of the intake and exhaust camshafts for better power delivery and fuel economy. IVTEC, intelligent VTEC. An improvement over VTEC, combining variable valve timing and lift control for better fuel efficiency and higher performance. Now let's learn about the functions of VVT. Improved fuel efficiency, by adjusting the valve timing according to the engine's speed and load. VVT ensures that the engine burns fuel more efficiently. At low RPMs, the system can adjust to increase efficiency and reduce fuel consumption, while at high RPMs, it allows for better air intake and exhaust flow to maximize power. Increased power output. VVT allows the engine to have optimal valve timing for different driving conditions. At higher engine speeds, RPM, the system adjusts the timing to allow more air and fuel into the cylinders, which helps produce more power. Reduced emissions. By optimizing valve timing, VVT helps the engine burn fuel more completely, which leads to more efficient combustion. This results in lower levels of harmful emissions such as carbon monoxide, CO, nitrogen oxides, NOx, and hydrocarbons. Better engine performance across a range of conditions. VVT allows the engine to perform better at both low and high speeds. At lower speeds, the system can help with smooth and efficient idling, and at higher speeds, it ensures that the engine can deliver maximum power when needed. Enhanced engine smoothness. Since VVT adjusts the timing based on driving conditions, the engine operates more smoothly, reducing vibrations, engine knocks, and the likelihood of fuel wastage. Benefits of VVT. 1. More efficient use of fuel. By optimizing the timing of valve openings and closings, VVT ensures that the air-fuel mixture is burned as efficiently as possible, reducing fuel consumption. 2. Increased power and torque. When engine conditions demand it, VVT adjusts to allow the engine to produce more power, especially at high RPMs, without sacrificing fuel efficiency at lower speeds. 3. Reduced exhaust emissions. By providing more complete combustion, VVT helps in reducing the emissions that result from incomplete burning of fuel. 4. Better engine response. With VVT, the engine can respond more dynamically to different driving conditions, improving acceleration and overall responsiveness. Example of VVT in action. 1. At low RPMs, idle or cruising at low speed, VVT retards the timing of the intake valve to optimize the combustion process for fuel efficiency and reduce engine load. 2. At high RPMs, acceleration or high-speed driving, VVT advances the timing of the intake and exhaust valves, allowing more air and fuel into the combustion chamber for increased power. In summary, variable valve timing (VVT) is a system that adjusts the timing of the engine's intake and exhaust valves to improve fuel efficiency, increase power, reduce emissions, and enhance engine performance. By changing the timing of the valves based on engine conditions, VVT allows an engine to perform optimally in a wide range of driving situations, making it a key feature in modern internal combustion engines.
Variable valve timing system was developed. The VVT system is a combination of hydraulic and electronic control system. VVT system ensures entry and compression of more air into the cylinder at low and middle engine speeds by closing the intake valve early, that is by advancing the closing time. This also opens the intake valve early and allows the entry of small amount of exhaust gases to the inlet side. This drops the combustion temperature and reduces generation of NOx pollution. VVT benefits. The above advantages result in better engine performance at all speeds, that is more power, lesser fuel consumption, and reduction of exhaust pollutants.
Thank you for watching this video. If you like this video, please like, share, and subscribe. Thank you all.